Hello, everyone. So in this video, I'm going to talk about how actually you can get a, I will say, relation for surface area of a cone. Okay, some people will call a formula, which is I'm not going to do that. But to do so, I'm going to explore the net of a cone just to see how that looks like. Okay, so if you want to unfold this, you are going to see something like this, right? And if you just like fold it, so you are gonna actually see this net of a cone. If you wanna put it back, it's gonna be exactly the same thing that we start with. But what I'm gonna ask you to pay close attention, the circumference of the circle at the bottom. So look at that one more time. So if you are really careful, let me actually kind of share. So the circumference of this cone, which is this around this circle, when you expand it, that will be actually same as this piece of that cone. Okay. So if you just put it back, so let me clear this. Just pay close to those two pieces for now. And if you continue opening that, the circumference of the circle will be actually this distance, which is around this like sector. So which is why I'm going to ask you actually to keep in mind with the original cone. So let me put it back one more time so we can actually have those two on the same picture. So let me draw this one more time so we can actually see how they are related after we fold it and unfold it. Okay, so if I want to kind of copy this one, let's assume this is my original cone. The reason I'm just doing this because I like you to see both at the same time, okay? So just imagine this is exactly the same as this one. And I'm gonna call, this is gonna be R. And if you wanna connect this point, let me use different color for this. If you wanna connect this to the top point, so that will be called my H, okay? And then this is gonna be 90 degrees. And whenever we have a cone, we usually like have two heights. This is gonna be called height of the cone that is perpendicular to the base. And there is another one, which is this guy, that is actually this in between the top point and between any points on the like circumference. And this is called slant height. Okay, slant height. And we usually use like L or whatever we want to use it. I'm going to use this guy for L. Okay. So let's say this is L. And what I'm going to do, I'm going to find a surface area relation between those values. Okay. But for us to do so, I'm going to kind of need to use my net of the cone. So which is why I'm going to open this one more time. And if I do so, this is going to be my net. The reason that I want you to like see both at the same time, because when I like fold and unfold it, you see that the circumference of the circle was actually this distance, this guy right here. So this distance all the way to the here is my circumference of the circle. And now I said this was R because that's what I call, and the circumference of the circle, which is, we should remember already, that is 2 times pi times R. So that is also same as this distance. But this distance is circumference of the circle, but at the same time, this is a arc for the larger circle if you want to extend this one. So if you want to kind of extend this way, okay, so you can just extend this one. You're gonna get a bigger circle with the radius of this piece. But if you were really careful, this guy was actually same as our slant height, which is actually L. Okay, so if you put it back, so you were gonna see that this guy will be actually our slant height. So again, if you are not really like seeing that at this point, maybe putting this back and making like cone and unfolding, that should help you to see this guy is actually the same as this guy. Okay, let me put it back one more time so you can really maybe focus on that slant height portion. If you just put it back, you know, you see this guy right here, this distance is actually gonna be this slant height. When you take it back, you know, put it back into that position. So you will see that that slant height, right? This guy is actually the radius of that larger circle that you could make if you want to. So now, if you want to find that distance, which is actually circumference of the circle, is actually a arc measure. But what is arc measure? So it's good to remember as well. So arc measure was, so let me write here. So arc distance, arc measure, or arc length, whatever you call, is equal to the angle at the center, which is, I'm gonna call this is alpha, alpha divided by 360, which is telling you portion of the full circle, times 2 times pi times radius, which is L in our case. Okay, so if the angle was 360, which means if this was full circle, then this is going to be 360 over 360, which is 1. That will be 2 pi times L, which makes sense because that's the circumference. But if you are talking about the arc length, which is part of the circumference, which is why we just need to divide the central angle by 360 to see what fractional part of that circle will actually be what we want, okay? So that is the circumference. This is the arc measure. But the question is now, you know, when you do this alpha over 360 and then multiply this by 2 pi L, that will give me this distance, which is that shaded arc part, which is actually going to be this guy. Let me write this right here. So alpha over 360 times 2 pi times L. And we already know this is equal to the circumference of the smaller circle, which is 2 pi times R, okay, 2 pi times R. Okay, just keep this in mind. But at the same time, our goal was to find the surface area of the cone, which is we want to find the area of this yellow region, which is a sector, plus area of this circle. So if you remember, the area of the circle was, let me write this, area of a circle is pi times radius squared, but area of a sector area is equal to the central angle divided by 360 times pi r squared. So the reason why we are dividing alpha by 360 because the alpha will tell us what fractional portion of the 360 is what we want to find out. So this is kind of like pizza slice. So based on the central angle, that will be determine the what fractional part we need to multiply the pi r squared. If this is 360, that will be just 1 times pi r squared, which is actually area of the full circle, okay? But we already know we want to find area of this region, which is alpha over 360 times pi r squared, right? But this r, this is a general reminder. So let me put this in right here. And this was also another one. So you want to find this, the area of this sector. So I'm going to say yellow sector area is equal to alpha over 360 times area of the larger circle, which is 2 pi times L squared. This is what we want to find, plus area of this circle. Okay, and I just don't know about alpha, right? So alpha over 360 is something I need to know, but I do know something like from the circumference. I did have this equation. So if I divide both sides by 2 alpha, these will cancel. And you know, alpha over 360 is something I like to find in this equation. So I can actually get something that I know. So I can divide both sides by L. So if I divide this by L, divide this by L as well, these guys will cancel. So from this equation, you have alpha over 360 equals R over L. So now this is something I got from my circumference and arc length. And if I plug this guy into right here, so you know alpha over 360 is R over L. So let me replace that, R over L times I times L squared. So you know 1L and R squared, so one of these will cancel. So you got yellow sector area is equal to R times pi times L. So this is like what we have. The area of this sector, like which is yellow sector, is R times pi times L. Let's look at original figure. So R is the radius of the circle of the cone at the bottom. That's the radius. And then L was the slant height, okay, which is right there. So you multiply R by slant height and multiply that by pi. And we usually write this as pi times R times L. So which is basically this area. Okay, but if you want to find the surface area of a cone, so you want to just add like this yellow area, which is the curve area, plus this circle area, which is the bottom part. So you need to combine those together. So that will be pi times radius squared, which is area of the base, plus the slant like curve area, which is pi times R times L. And then this is sometimes we want to kind of keep in mind, and some people want to memorize it, but I feel like if you know how to get this in the first place by using this net, so it's much better to like not to memorize, so maybe just get it whenever you need to. So it will take a bit less time when you try a few times. So that will be something much helpful, okay? But if this is too complicated for now, so maybe it's better to review the circle and circumference, like area, like arc length, basics before you move on to this question or this proof actually. But that is not too challenging when you have those background, okay? So that is my surface area. But in some places, you're gonna see this like formula a bit differently. Instead of having the L in our equation, they will have something else, which is why I'm gonna kind of touch base on it as well. You know, this is a right triangle. If I use a Pythagorean in this triangle, so you do get this. H squared plus R squared is equal to L squared. So if I want to find the H alone, okay, so that could be, you know, this could be H squared is equal to L squared minus R squared. And if I want to take the square root, which is gonna be something a bit not nicer maybe, so that will be H, and then that is L squared. So let me pull this. So this was L squared minus R squared. And then you can just write this one instead of L if you want to, which is gonna give you pi times R squared plus pi times R times, which is L squared minus R squared, which doesn't look really nice as you see. So you can write something like this, but this is much better than this one. Only thing is I just use a Pythagorean to write my formula in terms of radius and height of the triangle. So instead of slant height, okay? But still, you can use either one. There is no big difference. So I think that should be all good, okay? So I hope that makes sense. Let me know if you have any question. I'll see you in the next video, okay?